that is to say in the electrolyte solution. Now, when we have two ions competing for discharge, the fact remains that the ion that is lower in the series will be discharged in preference to the ion that is higher in the series. That is one fact that has been established. But if we have a case where the ion that is lower in the series is of a higher concentration, a very high concentration, then it is going to be discharged in preference to the one that is lower, even though the one that is lower in the series should be discharged. But because this other ion is of higher concentration now, then it will be discharged. That is actually what concentration is talking about. So, having seen what concentration is all about, as we have explained, let us take an in-depth explanation and view of concentration. So, if we have, let's assume we have AB dissociating in water as electricity passes through it. This is electrolysis of a solution, a salt solution, AB. So, we're going to have A as A plus and B minus, and water also dissociates as hydrogen ion and hydroxide ion. So what it simply tells us is that A plus and hydrogen will migrate to the cathode. That's what it tells us. They both migrate to the cathode. And we have B and OH migrating to the anode. So what happens at this point? It tells us that if between B and OH, B minus and OH minus, OH being the least in that family ought to be discharged in preference to B, but this time around we are having high concentration of B, then OH will stay back in the solution while B will be discharged at the anode. Similarly, we have A plus and hydrogen at the cathode. If the concentration of hydrogen is quite low, such that the concentration of A is way more than that of hydrogen, very concentrated, then it means A will be discharged at the cathode. It is, however, worthy to note that the effect of concentration takes preeminence when the distance between the two ions are close. So when we have a close distance, that is when concentration takes effect. So it is worthy to note this, that close distance actually promotes the effect of concentration. A good example is, as we can see, between tin and hydrogen, lead and hydrogen. These are cases where we can say the effect of concentration can take place. So if we have more lead, concentrated lead, as a matter of fact, compared to hydrogen, instead of hydrogen being discharged in preference to lead, then lead will go. The same thing also to tin. So that is actually what we have, just like we have here chlorine and bromine, chlorine and bromine, chlorine and iodine, and also chlorine and OH. So when we have, looking at chlorine and OH, if the B minus, for example, is the chloride ion, and we have more of the chloride ion, that is concentrated chloride ion, then it means that the chloride ion will be preferentially discharged as against OH that should have been discharged. Why? Because we have higher concentration of the chloride ion. And the same thing also in the case of A and hydrogen, we have higher concentration of A. So this is actually what concentration is all about. So concentration takes effect when we have a close distance between the ions. But if the distance is much, If they are far apart, then the effect of concentration will be useless. That is actually what we should know about concentration. Away from concentration, now we shall take a look at this example. We have copper 2 tetraoxide sulfate 6 is electrolyzed using carbon electrodes. What are the species that are produced at the anode and the cathode respectively? That is the question for us. Now, let us consider this question and see what happens. We have electrolysis of copper 2 tetraoxosulfate 6, and we are told that carbon electrodes were used. Carbon electrodes are actually inert electrodes. There are examples of electrodes that are called inert. That is to say, they do not participate in the reaction. So let's take a look at that. We have copper sulfate. As it goes into water and electricity is passed, we are going to have the copper sulfate split into copper ions and SO4 2- ion. So we have water also split into hydrogen ion and OH ion. Now let's see what happens. So at the cathode, copper and hydrogen migrates to the cathode because they are cations. Cations, cathode. Cathode, cations. Cations is cathode ions. So they migrate to the cathode. As they migrate to the cathode, who will be discharged at the cathode? We can see between hydrogen and copper, copper will be discharged at the cathode because it's lower than hydrogen in the electrochemical series. So copper will be discharged at the cathode. Between SO4 and OH, who will be discharged at the anode? SO4 is higher than OH, so OH will be discharged at the anode. So as OH is discharged at the anode, it simply tells us that it will eventually become oxygen. Oxygen will be discharged at the anode because this will actually give out electron and eventually we have oxygen. We've done that equation before, but for the benefit of maximum impartation, let us still carry it out again so that we can get to be used to that. So this is OH releasing electrons and it will become OH neutral as it gives out its electrons. So the OH combines with other OH to give us water plus oxygen atom. The oxygen atom can't stay alone like that, so it combines with other oxygen atoms to give oxygen gas, oxygen molecule gas. In the case of copper, at the cathode side, this is what happens. Copper 2 ion gains 2 electrons to become copper solid. This is copper aqueous. So this is actually what happens at the cathode and at the anode. So copper is being released there. So this is actually what happens according to that example. So it is done. So we proceed to our next example. But before then, let us consider what we just did. So we can see in the solution, copper sulfate solution. So copper and hydrogen migrates to the cathode. SO4 goes to the anode. And there we have, as you can see displayed, the electrolyte ionizes. As the electrolyte ionizes, all the species migrate to cathode and anode respectively. At the anode, the OH is actually discharged at the anode, and we have oxygen gas. But at the cathode, copper will be discharged at the cathode. So that is what we have there. Okay, now let us look at the condition where we have a concentrated solution. Since we are talking about the effect of concentration, so what happens when we have a concentrated solution? Let's look at the electrolysis of molten sodium chloride. So when we talk about the electrolysis of molten sodium chloride, we are talking about in cases where we have a concentrated solution, for example, what becomes of this electrolysis? What becomes of the species? So what becomes of the species is we are asked which substance are collected at the cathode and anode when concentrated sodium chloride solution is electrolyzed using platinum electrode and of course carbon anode. So what do we do here? And these are options given to us. So what would be our answer to that? Now to answer that question, let us proceed. This is actually what happens. We have sodium chloride ionizing and water also ionizes. So at the cathode, hydrogen and sodium ion migrates to the cathode. There, because we have a concentrated solution of sodium chloride, it means sodium ion is very concentrated. It ought to be discharged preferentially, but because the distance between sodium ion and hydrogen ion is too much, so for that reason, it will actually become useless. The concentration of sodium ion becomes useless. That is actually what we discussed before. So the concentration of sodium ion becomes useless even though it is very, very concentrated. But in the case of chloride ion at the anode, chloride ion migrates to the anode together with the OH ion. Now because sodium chloride is very concentrated, sodium chloride, so as sodium ion is concentrated, so is chloride ion concentrated. Don't forget, OH ion is coming from water, but chloride ion is coming from the salt. So, and we are told that the salt is a concentrated salt. So, which means sodium ion must be concentrated and chloride ion also must be concentrated. So, since chloride ion is concentrated and the distance between chloride ion and OH ion is not far, then the effect of concentration takes preeminence. Generally, the effect of concentration applies more to anions than to cations. So what it simply means is that at the anode, the chloride ion will be oxidized at the anode. And as it is oxidized, it loses electron, becomes oxidized, and we have the chloride atom combining with another chloride atom to give us the chlorine molecule. So this is actually what happens or what takes place at the anode when we have a concentrated solution. So with that, we conclude everything about effect of concentration. We look at our next condition, which is the nature of the electrodes.